Unit 2, Lesson 1, Quadratic Functions. We are now going to practice 8 different quadratic equations and how do we solve them using the factoring method. As a reminder, the factoring method does not always work, but it's the most practical way to solve. This tells me that there will be at most 2 solutions. Let's get started. So I'm going to ask myself, what is the A, what is the B, and what is the C? It's not necessary for you to write down A, B, and C. If you're watching this video because it was assigned to you, please know that you do need to take notes. This A, B, and C is really there for students who are relearning this or who never mastered it the first time. I'm going to take A times C to get a positive 24 and combine to give us a positive 11. And now I'm thinking in my head, what are the combination of 2 numbers that multiply to give me 24? Now as I start this, I'm going to show you what the thought process in my head. But as I move through the examples, I'm not going to continue to show you all of this work. So 1 and 24, both positive and negative, does not give me 11. 2 and 12, positive and negative, does not give me 11. 3 and 8, okay, positive 3 and positive 8 does achieve a positive 24 when you multiply, and they combine to give me 11. So I'm going to write down the A, I'm going to write down the C, and now in this middle portion I'm going to drop in the positive 3 and the positive 8. Don't forget, they both need an X behind it. And now I'm going to use the method what's called factoring by grouping. I can factor out at most a 1x. 1x times 1x is 1x squared. 1x times 3 is 3x. I'm going to copy and paste the 1x plus 3 in the back, and I'm asking myself, what number times 1x is a positive 8x? Don't forget about the sign. That would be a positive 8. Now, if this is the correct value, positive 8 times positive 3 will achieve a positive 24. Once we've had that identified, we look at both the left and the right. We see they both have a 1x plus 3. I write it down one time. In front of the first part is a 1x, in front of the back part is a positive 8, and I'm just going to set each of these quantities equal to 0 and I'm solving. So 1x plus 3 equals 0 and 1x plus 8 equals 0. Now I have taken trainings for APSI, and I know that if you would be asked to do a problem like this on the AP exam, that in the part that's the non-multiple choice section, and you're asked to do it either using a calculator or non-calculator, you would have to show your work. And so it just seems, I get it. You're like, do I really need to show all of this work? You do. So get used to it. I'm going to subtract 8 from both sides. I have a negative 8 divided by 1, and I get a negative 8. So right now I'm looking at values of negative 3 and of negative 8. Remember, like I told you, we now have to check for what's called extraneous solutions. You do all the math correctly, but you plug it back in, it may not work. So unfortunately, I don't have a calculator here. If you had one, I would just plug it into a calculator. But here we go. Negative 3 squared is 9. Negative 3 times 11 is negative 33 plus 24. So I'm going to subtract 9 here to end up with negative 24, and negative 24 and positive 24 is in fact 0. So I know that negative 3 works. Now we could try negative 8. Negative 8 squared is a positive 64. Negative 8 times 11 is going to be negative 88. Now I'm going to, for the purpose of this video, I'm going to already check these in advance moving forward so I don't waste 30 seconds to a minute for every problem showing you how to check. Again, you're welcome to take a calculator, but here's the helpful hint that a lot of students don't understand. When you plug in any value, you have to put in parentheses. So if you were plugging in negative 8 and you don't use a parenthesis, you will not achieve the right value. So this is how you plug it in and then see does it equal 0. So when I plug in negative 8, again I do the work here, I get negative 24 plus 24 is 0. Those 2 answers check. Okay, moving forward, again we are going to assume that I am checking ahead of time to make sure that it works, just to save ourselves some time. Let's look right now at example number 2. So example number 2, I start by making what looks like this, and I'm going to go 1 times negative 24 is negative 24. I'm looking for 2 values that multiply to give me a negative 24 and combine to give me a positive 2. Okay, 1 and 24, that doesn't work. 2 and 12, that doesn't work. 3 and 8, that doesn't work. By the way, it's negative. That tells me that the 2 values have to have different signs. 4 and 6 could work. So I'm going to write down 4 and 6, 12. 1 times the 4 is negative, the other times the 6 is negative. I look at these 2 combinations and ask myself, which one combines to give you a positive 2? That's going to be this combination. Common question asked by students who maybe didn't master this at their algebra 1, 2, or 3, 4 level is, does it matter if I put the 6 first and the negative 4 second, or vice versa? Makes no difference. All right, so this is what I have right now, and I'm going to drop down the A, drop down the C, and in this position, I'm going to put in my values negative 4x and positive 6x. Okay, working through this just a little bit quicker for you. I can factor out a 1x, I'm left with 1x minus 4. I repeat what was in parentheses, which is 1x minus 4, and ask myself what times 1x equals a positive 6x. That would be plus 6. So 6 times 1x is 6x, and 6 times negative 4 is a negative 24. Okay. The front and back both contain a 1x minus 4. In front of the first parenthesis is a 1x, in front of the second is a positive 6. I'm going to set both of those equal to 0, both of those quantities, and solve. Now, as we go through the next examples, I'm going to teach a different method. It's the method that I learned growing up, and it seems like a quicker method for me. Remember, you are able to use whatever method works for you. So I have negative 6 and I have negative 4 for this example, and I'm checking my work right now. Give me a second. And that does work. Negative 6 and negative 4 do work for this. Oops, sorry, here. Let me look at my work here. Positive 4 and negative 6 do work for this particular example. When we go down to example 3 and 4, I'm going to show you what's called the bottoms up method. So this part of factoring, I use factoring by grouping. Down here, I'm going to use what's called bottoms up. And you could choose either. You may ask yourself, Ms. Bradley, why would you choose to do a different option? Well, I show example 1 and 2 because I know that most freshmen learn it that way. Example 3, 4, 5, and 6, I know that moving up to calculus, we want to find more efficient ways to do it, and that's why I choose to use the bottoms up method. It's taught by the teachers moving up. I want you to be exposed to it. So it all starts out in a similar fashion. So when we look at example number 3, I'm looking for two values that multiply to equal positive 24 and combine to equal negative 14. And so let's go here. We have 1 and 24, no. 2, again, if you're a visual learner like myself, let me just do a little more of this before I just go back to explaining the process rather than writing down all the steps. So 2 times 12, oh, 2 and 12. This says they have to be the same sign, and this says they have to combine to give me negative 14. Multiplies and combine. Oh, I like that. Okay, now are you ready? This is called bottoms up, and I want you to understand because I'm going to use what I think is the fastest method. And so you're going to see me move, as we move forward, often doing bottoms up. Here's how it works. I make two parentheses, set it equal to 0, and it's going to be x subtract 2 and x subtract 12. It won't matter if I put the subtract 12 in the first parenthesis or the second parenthesis. What matters is I have these values with the correct signs. Okay, you ready? Then whatever's the leading coefficient has to go underneath those numbers. So x minus, oh, that simplifies to 2. And 12, oh, that simplifies to negative 12. Now you're thinking like, why do you like this method, Ms. Bradley? I like this method because, you ready? I want to set each of these equal to 0 and solve. Then you're going to go back and you're going to circle the value and the number that's behind it. Did you hear that? So the value and the sign, I meant to say it, behind it. And whatever is opposite of that is your answer. X equals 2 and x equals 12. Done. Those are the two answers. Simple as that. Let's look at example number 4. That's why I prefer this method. What multiplies to give us negative 24 and combines to give us negative 5. Okay, you ready? I'll do one more where I kind of go through those options. 1 and 24. This tells me they're going to be different signs, and this says the combined they're going to give you a negative 5. 1 and 24, that's not going to be negative 5. 2 and 12, no. 3 and 8 can give me a 5 if they're different signs. Now, if they're different signs, and I end up with a negative 5, that means the large number has to have a negative. So positive 3 and negative 8, positive 3 and negative 8. I make my two parentheses, set it equal to 0, x plus 3, x minus 8, and I take whatever is the leading coefficient, makes it easy when it's a 1. Okay, well, I can simplify 3 divided by 1 is 3, 8 divided by 1 is 8, and now, after I've done that, because it's going to be a little bit harder when the leading coefficient is not a 1, but it's still a simpler process, that I'm going to circle, and I go, what is the additive inverse, or what is directly opposite of positive 3? Negative 3 and positive 8. Those are our two solutions. let's go on now to harder quadratic equations to solve, but let's use this method that's called the bottoms up. All right, let's look right now at example number 5. Now, don't be intimidated by this problem. Let's start off to the side. What multiplies? Okay, 5 times 12. I don't have a calculator at home. I was in a rush to leave at 11 o'clock, and so I need to take my time and think through these process. Okay, you ready? Things that multiply to give us negative 60. So I know they're going to be different signs if they multiply to equal negative. So 1 and 60 now. 2 and 30. Oh, 2 and 30. 2 and 30 can multiply to give you 60. And to get a negative 60, they'd have to be different signs. Like one would have to be positive and one would have to be negative, if that makes sense. So positive, negative, or negative, positive. Now, one of these combinations does give us a positive 28. This would be it. And you're going to see right now why I like this method. So here's why I like this bottoms up method. So I make 2 parentheses. I set it equal to 0. I drop down the x, subtract 2, and the x plus 30. Now here's the part that a lot of students forget. You've got to go up to that leading coefficient and put it underneath every time. And then you have to ask yourself, can you reduce? Well, 2 over 5 can't be reduced, so I leave it just as is when it can't be reduced. 30 over 5, yeah, 30 divided by 5 can be reduced to 6. Once you reduce it, you circle the value, and that includes the sign in front of it. And now we have x equals opposite is 2/5, and opposite is negative 6. I want to know if you're watching this video. If you're watching this video, you're going to be asked, which method do you prefer? And remember, you get to choose what makes most sense to you. So you can choose what is referred to as factoring by grouping, or you can choose what's referred to as the bottoms up method. Let's keep going. All right, 12 times 7. What is 12 times 7? That is a positive 84. So I'm thinking of 2 numbers that multiply to give me an 84 and combine to give me goodness. This is really making me think. Okay, so let's get going here. Let's see what we get. I'm going to start here with 84. So 1 and 84, that's not working. 2 and 42, that's not working. Is 84 divisible by 3? Let me do some math here. 3 goes in 2 times. I don't think. Let's just do this really quick. Goes in 2. I'm regretting. Oh, it does go in. Okay, so what about 28 and 3? That doesn't work. Okay, so 3 and 28 doesn't work. I know it's going to go in 4 times. Let's check how many times. Hopefully you guys see that's 21. So 21 and 4. 21 and 4. I'm getting close here. I'm getting very close. 5 doesn't go in. Let's go in 6. I'm really regretting not bringing a calculator home right now. 6 goes into 8 once. 6 does not go in. So you can see 6 does not go in an even number of times because 6 doesn't fit into 26. It can't be 6. Let's keep going here until I find this combination. You know what? I'm seeing it right now. Here's a helpful hint. You ready? 7. Helpful hint here. 7 goes in 1 time to 8, and 7 goes into 14 twice. So 7 evenly fits into 84 12 times. And look at 7 and 12 add up or combine to 19. So 7 and 12. They multiply and they combine. So I'm doing the bottoms up. You may have never learned this, and I'm talking fast, and you're thinking, what is she doing? So let me come back here again. I'm going to drop into these spaces. They were both positive, so x plus 7 and x plus 12. And then here's the part that a lot of students forget. It's taking that leading coefficient, no matter what the value is, you're going to put it underneath both values, and then you're going to reduce. Well, 7 divided by 7 is 1, and 12 divided by 7, it can't be reduced. Now, I'm going to circle both of the value and the sign of each, and I ask myself, what's opposite of positive 1? Negative 1. What's opposite of positive 12 sevenths and negative 12 sevenths? Again, you'd be going back every time, plugging it back into your calculator to make sure that it's not an extraneous solution. And if that's a new term for you, as a reminder, extraneous solution means you do all the math right, but when you plug it back in, the left side is not going to equal the right side. What I would like you to do is I would like you to see, can you do this on your own? So I'd like you to press pause on the video, complete 7, complete 8, and then come back and press play to see if you've got the same answers that I achieved. All right, so hopefully you're back with me now. I'm taking a times a c to equal negative 36, and we want 2 numbers or 2 values that multiply to give you a negative 36. They're going to be different signs, and combine to give me a negative 5. Okay, 1 in 36. And you can see factoring is so much based on your ability to do it quickly, is based on your multiplication skills. So 1 in 36, that doesn't give me 5. 2 in 18, that doesn't give me 5. 3 and 12, okay, I'm getting closer now. Ooh, 4 and 9, I could get 5. If they're different symbols, but they have to combine to give me a -5, it's either going to be a -4 or a -9. I have to achieve a -5. That means the 4 is positive and the 9 is negative. So if you chose to use the bottoms up method, I would start like this. Then I'm going to drop in the +4 and the -9. If you happen to put a -4 and a +9, you were close, but it's wrong. You do have to have the right value and the right symbol with it. Now, the leading coefficient is a 3, and I'm guessing a lot of you forgot that. 4 divided by 3 does not reduce. 9 divided by 3 reduces to 3. After I've done this, I'm going to take each value, circle it along with the sign in front. What's opposite of a +4/3? A -4/3. What's opposite of a -3? A +3. Those are my solutions. I have checked them prior to doing this, and they both were, which means they're not extraneous. Let's look at example number 8 before we finish this video. 2 times 12 is a +24. I'm looking for two values to multiply to give me a +24, combined to give me a -8. This time I'm just going to verbalize. Okay, 1 and 24, no. 2 and 12, no. 3 and 8, ooh, 3 and 8. So 3 and 8 means they have to be the same sign to get a positive, so they're both positive or both negative. And we can see they would both have to be negative to achieve a -11 when you combine them. So I'm dropping down 2 parentheses, and then inside would be x minus 3 and x minus 8. Don't forget the leading coefficient. Now 3 divided by 2 cannot be reduced, so I leave it as is. 8 divided by 2 does simplify to 4. Once you've simplified it, you're going to circle the value and the sign, and what's opposite of a -3/2 would be a +3/2, and opposite of a -4 would be a +4.